Ladies and gentlemen, we are going to take a look at arithmetic sequences for the second time here. You've already watched the first video explaining arithmetic sequences, and now we're going to do a real-life application of arithmetic sequences. And we have a problem, or we have a situation on the board in which we want to rent a DVD that costs $4 to rent. And then after a day, it costs you 45 cents for each additional day. I want you to write a function, or we're going to write a function that describes this arithmetic sequence, and then we're ultimately going to graph it. So again, to clarify the problem, it costs $3.95, or it costs $4 to rent the DVD for a full day, and for every day after that, it's going to cost you an additional 45 cents. So, function. We need to know how much it costs to rent the DVD, which is our output, or y. And we know that has to be equal to some data. We know that up front it costs $4. That is going to be our y-intercept. And we know that it could cost us another 45 cents for each day that we rent it, which is going to be our x. Okay, for each day that we rent it past the 1 day. So if we just use it for 0 days, and we plug in that information, we want to know how much it's going to cost us if we rent it for just that 1 full day, not for an extra day. So it's going to be 45 cents. We didn't do an extra day, so we did 0 extra days, plus $4. And you're going to see that that's going to cost you exactly $4. Okay. Again, I'm going to have to erase here to show you what would happen if we're going to rent the DVD for a full extra day. Y equals 45 cents times 1 extra day plus $4. You do your math. We know it's going to cost $4.45 to rent this DVD for an extra day beyond the day that you actually get it for. So with that, we want to program this into our computer at the store because we have no idea how many days each person is going to want to rent each DVD. So we want to have a computer that does all that for us. So we're going to graph the function. We know that y equals mx plus b, and we are now very good at what each of those letters represent. We know that the arithmetic sequence is going to be 45 cents for every single day. So we're going to go ahead and graph this in the fact that $4, 1, 2, 3, 4, is going to be where our y-intercept is. And our slope looks like it's going to be 45, or almost 1/2 over 1. So we're going to do a rise of 45 and a run of 1 for each day that they rent it. So imagine that's 45. 45 rise, run of 1. We're going to be almost to the next line. Rise of 45, want to run. We're going to be a little bit below half there, and we can keep on keeping on. In this situation, we're going to create a line that is only going to be a one-way line because we can't, or the store is not going to charge us or give us money for the DVD. We know no matter what, when we rent it, it's going to cost us $4, and we know that for each extra day, so this would be day 1, this would be day 2, this would be day 3, this would be day 4, this would be day 5, this would be day 6, 7, 8, and so on. We can figure out, or the computer can figure out, how much money is owed to them. This being our starting point of $4, this being $5, this being $6, this being $7, and so on and so forth. Again, arithmetic sequences, we have our m, and our m is going to be the increase. It's going to be the same every day. It's going to be 45 cents for each day, so therefore it's going to be the same increase, with x being our input and y being our output. Good luck.